Okay, today we are going to look at functions, domain, and range, and we're going to do this foldable that we can glue into our math notebooks. On the first flap, there is a place to put your name. If you want to do that, you can, but these will be glued into your notebook, and so it's not really that big a deal if you don't want to do that part. Okay, so first we're going to look at the difference between a relation and a function. So a relation is a set of ordered pairs, which basically we usually think of as being points. They can be given to you in a list. If they do that, they will use these little curly brackets like this. It might say 5, 7, -2, 1, or 3, -8. They're going to give you a list, and they will often use these little curly brackets that groups that together, and that is considered a relation. I'm going to draw a line here so you have a difference between the definition and what's down here. You can also have a table. They might put X and Y like this, and they might say -5, 2, -3, 4, to -1, to -5. They can have just a list of points this way, or they might also give you a graph where you have some points on the graph. They can be wherever. So all of these are relations. They're a set of points. Now if we go over to what a function is, it's a special kind of relation. So it's a relation that assigns one output, which is a y, for every input, which is an x. And the big idea here is when you look at it, the x's will not repeat. So I'm going to put a little bubble around that. The x's will not repeat. So over here, where I have the 2 and 2, that would not be a function. It is a relation, but it would not be a function. And we're going to explore this a little bit on the other flaps. But first we have to get a little bit more vocabulary. So in the next flap, we talk about domain and range. So domain, I'm going to do this first. I'm going to put parentheses and the X here, the comma in the middle, and the Y over here. The domain is the X's, and the range is the Y's. So the domain is the set of X values. It is our inputs, and it represents the independent variable. Okay, if you need to pause the video to write those down, you can. Let's go over to the range. The range is the set of y values, which is the outputs, and it represents the dependent variable. Okay. So if we had a set of points, all the x's go in the domain, all of the y values go into the range, and that's it. All right, let's take a look at what we call the function machine. It's labeled down here at the bottom, function machine. We get that all on the screen. So for the function machine, we think of a rule. So you might have a rule that says y equals 2x plus 3. Our x value that we're going to put into that rule, it's telling us they want to put in 4. So 4 is going to go in where the x is. So that would mean I would have 2 times 4 plus 3, which would be 8 plus 3, and we get 11. And so 11 is what comes out. So this is the output, and the 4 is our input. This is the number we're putting into the equation. This is the number that we're getting out for the y. Okay? So for that rule, we're going to copy it over here, y equals 2x plus 3, and talk about making a table of values. So they've already done some of these for us. This is the inputs, the x's. This is the outputs. This is the domain. And this is the range. Okay? So they've already done several of these for us. Let me explain where these are coming from. So we already did 4 going in, 11 coming out. Let's look at -1. So -1 is the input. So you would have 2 times -1. Oh, here, I'll go ahead and use parentheses for multiply. 2 times -1 plus 3. So that'd be -2 plus 3. And then the output is 1. On the next one, they have 2 as the input. So that'd be 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. On the next one, 9 is the input. So 2 times 9 plus 3. So 2 times 9 is 18 plus 3. So this would be 18 plus 3, and that's where they get 21. You can put in 0. 2 times 0 plus 3. 2 times 0 is 0. 0 plus 3 is 3. So now we can pick some other just random numbers. So let's say I pick 7 for the input. So I would do 2 times 7 plus 3. So 2 times 7 is 14 plus 3 is 17. Or maybe I want to use 3 as my input. So I would do 2 times 3 plus 3. 2 times 3 is 6 plus 3 is 9. So on each of these, this is the input number, and that goes in where the x was. Just making sure that we're keeping track of what we're doing. So the rule was 2x plus 3. We're putting the input in for the x. All right, so let's pick a -1. Let's say we have -5. So I would take 2 times -5 plus 3, which would give me -10 plus 3, which gives us -7. Okay, so we know that this is a function because the x's do not repeat. So I'm going to put a little note down here. The x's do not repeat. And that's because when I put this number in, there's only one answer that comes out if it's a function. So if I put 4 in, there's only one possible answer for each of these. Each of these inputs is only going to give you one output. Now in high school, we'll have some equations where sometimes this doesn't work out and it's not a function, and we just have a relation. And so I'm just pointing out to you, I guess you can't see what I'm writing, that none of these x's repeat. The x's do not repeat if it's a function. Okay, so now we're going to do a couple more examples along those lines. So the directions at the bottom say, is it a function going from a table? So what we're looking at is seeing if any of the x's repeat. Well, I see -1 repeating. Okay, there's a repeat in the x's. That means that this is not a function. Okay, let me zoom in so you can see that better now that we've talked about the directions. If I come over to here, I'm only looking at the x's. So in the x's, there's no repeats. So this is a function. So this is my answer on both of those. Now there is a repeat over here on the y's, but we don't care about that. This is okay. This is okay to have the ones repeating over here. We only care about the x's. All right? So then, let's talk about how to tell if something is a function looking at a graph. And we're going to look at what's called the vertical line test. So, any vertical line drawn should intersect only one point of the graph. Okay? So you can't have points lined up above each other. I'm going to use some color just so you can see this. So I have a point over here. If I put a vertical line through that, it's hitting 1 point. Here's another one over here. If I put a vertical line through that, it hits 1 point. If I do a vertical line through this one, it only hits 1. Vertical line through that one only hits 1. So this one is okay. It is a function. Any vertical line that I drew that hit points on the graph only hit 1 point. Now on the next one, we run into an issue. It hit 2 points, one here and one here. They're lined up above each other. That means they have the same x values, and that is not a function. Okay? And that's because it's hitting 2 points. It hits 2 points in that one spot. Now these would have been okay, 1 point and 1 point. But if anywhere on the graph it does this, you know it's not a function. All right, let's look at the last one that just has points. So over here, this is okay. That's just 1. When I draw a line over here, though, I hit 2. 1, 2 points. So automatically that means this is not a function because it hit 2 points. Now it could be more than 2. It could be 3, 4, 5. If it's more than 1, it's not okay. So something we haven't looked at yet is what if they have graphs where they've connected all of the points. So these are some funny looking graphs. This is my graph right here. If I drew a vertical line over here, it only hits 1 point. But as soon as I come over to this part of the graph, it hits a point here and down here on the graph. Same thing here, there and there. It's hitting more than 1 point. So we're going to say that this is not a function. The same thing will happen with a circle. If I draw a line right here on the circle, or anywhere other than the sides on the edge, then it's going to hit more than 1 point, and we will say that that is not a function. And then over here, we have this wavy graph. We might have to look at it a little closer. So if I do this line, it only hits 1 point. There it only hits 1 point. There it only hits 1 point. 1 point. 1 point. 1 point. As long as it's only hitting 1 point at a time when you draw those vertical lines, it's okay. This is a function. All of the vertical lines only hit 1. This one only hit 1. This one only hit 1. So it's okay. It's okay. It is a function.